Okay, so hello everyone. Okay, so now this is more like a transfer of knowledge of what we've learned, but now we are using proportion instead of S bar. We are now dealing with proportion. The S bar had a standard deviation for which you multiply z half over 2 by 8. But now the p hat also has a standard deviation. That is what you see. That is p hat times q all over n, where q is 1 minus p. Then you take the square root of it. We've learned this before coming to this. Okay, so now we are dealing with large sample. We know that if you are dealing with large sample, then we use z half over 2 rather than t half over 2 with some degrees of freedom. But how do we know that we have large sample? Okay, that is the rule of thumb. Okay, if you multiply your sample size by the p and it is greater or equal to 5 and kill n by kill and is greater, both should satisfy, not one, then you have a large sample. If that happens, you are good. You create some kind of interval to estimate your proportion. So that is that. So how do you get your proportion? Proportion is S over N. The S is what we are interested in over the total sample size that we have. You are good to go. All right. So let's see some example. It's the same thing, nothing changes, just transfer of knowledge. Of in the S bar, we are bringing it back towards the P, and we do just that. So the confidence interval for PR. So we wanted to estimate the proportion of students at a large college who are female. So our focus is on female. Okay. So we took a random sample. We have N to be what? 120. And there are 69 females. So we are focused on female, 69. So out of these students, we have 69. This implies that male might be n 120 minus 69, then you get that of fat males. So what do we have to verify that the sample size is large. Then if possible, construct a 90. So this is our C, 90% confidence interval for the proportion of all students at the college who are female. Okay, so we are to interpret our results. So we are focused on female. If it was male, then we have to use our S. S would be 120 minus what? 69. Okay, that would be the male, but the confidence interval you are creating is for female, and we are giving the female number already, so we are good to go. So what is the proportion of female out of this n? That is 69 out of what? 120. So that is the proportion that we know, in case you want to use a step-by-step approach. So you have that. That's your p hat. You are good to go. Your S is 69, your N is 120, and we are talking about female. It's not male. So we check whether our sample size is large. So N times P or p hat, we get more than 5. That is 69. We do same for Q. We get 51. Then we have a large sample. We are good to go. Okay. So there's a calculator way of also getting the interval at once. Okay. So this is, since we are using z half over 2, this will hold irrespective of, and this is how we get the z alpha. We've done that. It's just the same thing, nothing is changing, but now we are using p hat instead of s bar. Okay, so let's see, how do we use the calculator? So that's the short way of doing it. In case you want to go the long way, then you identify your p hat. So this is the p hat, and this is, you read this from the your calculator, and you do this as well. So your Q will be 1 minus that. All over, it takes the root of that. You're going to get the same answer that the calculator is going to give you. So that is the answer that you get if you are doing it in the long approach. But if you use your calculator, then you're going to get the same answer. All right, so let's follow what the calculator gives us. So we're saying that you go to stats, then you go to tests, then you choose one proportion, not z test, one proportion z interval. So after 90, you come to A. So this is what you choose. Then it's going to ask you, what is your S? 69. Your N is 120. What confidence level are you using? 95. Then we insert that. What was the confidence level? Let me check again. So it's 90. You have to construct a 90. All right. So let's verify that. Okay. So the same information, but we are using what? 90. So 0.9 or 0.90. That works. Then you're going to get All right, so that is the correct interval. Okay. So we do the same for all of them. So this is luxury or necessity. So it's two things, like male or female. So what confidence interval are you going to consider? Is it on the luxury or on the necessity? So we just focus on which confidence interval. So then you have to get the p hat for that. If it is luxury, how many luxury is in the sample? Okay. If it is necessity, how many necessity? So 5 to 1 indicated that's television. So luxury is 5 to 1. Then necessity will be the 1003 minus 5 to 1. That will be necessity. Okay. So if you have to do that, so you have to obtain a point estimate. Point estimate is what will represent the population proportion. Okay. So that is p hat. That is 5 to 1 over that. But this is the point estimate for luxury. But you can also get point estimate for necessity, and that will be 1003 minus 5 to 1 all over 1003. Right, good. Or you subtract this from 1 and get the opposite. So you have to verify the requirement for constructing interval by P. So you have to check whether n is large. That is that. Then you do your confidence interval bit. Okay, so we are focused on large. That was success. So what is the S? S for large is 5 to 1, and N is that, and 95 is that. Yeah, good. So after constructing the confidence interval, you realize that the margin, the interval is 0.488 to 0.555. So this is the proportion of those that will lie within that interval. But the question asked in D is it possible that a supermajority that's more than 60%, the upper level or the upper interval for the confidence interval is 0.555, which we can't go above that. Okay, so yes, it is possible. If it is possible, if we're able to actually increase our confidence level, because if you increase the confidence level, your interval widens. Okay, but with respect to this confidence interval created, it's not likely. It's not likely that you're going to get that. Okay, so that is that. That is why you're saying yes, it is possible, but it's not likely. So if you want to explain based on the confidence level game. So we are 95% confident that the proportion. So out of this question, you use it to. So we are 95% confident that the population proportion of adults who believe that they is between what. Then you use this. You bring your interval. You are good to go. That is that. So you have to use the results of part C to construct a 95 for the population proportion of adult American who believe that. So now we are using necessity, not luxury. So take the opposite of it. Okay, so now S will be 482, not 5 to 1, because that's the opposite of it. So you construct, so notice very well, which one are we considering? All right, so we do that and we get this. Instead of 5 to 1, the reason why we have 482 is that we have 1003 minus 5 to 1. That gives us the necessity part. Then we do a confidence interval for that. Okay, that is that for the proportion. If you have any question, please do to ask me.